Hi, my name is PK. My selected language is Rust. In this presentation, I will compare Rust with C using three features: polymorphism, memory management, and concurrency. My main point is that Rust still give low-level control like C, but Rust asks the compiler to check more things before the program runs. So uh, according to our final projects, we have to choose one language and compare three important features with C. And polymorphism and memory management are required, so I will cover those first. And for my third feature, I chose concurrency because my project A gave me a good comparison between C pthreads and Rust pthreads. So my main argument is that the biggest difference I notice is not that Rust hide low-level details. Rust has pointers, heap allocation, threads, and performance-focused code. So the difference is that Rust makes many rules explicit, and in C, the programmer must remember the rules, but in Rust, the compiler helps enforce those rules. And this is my first feature, polymorphism in C. So I made a very generic linked list by storing data as void pointer. This means the list does not know the real type of data. It can store an integer, a docstrack, or something else. But because the list does not know the type, that means I also need callback function like a compare function, a map function, or a free function. And the trade-off here, uh, this works because this works, but still there is a cost. The compiler cannot check if I cast the data correctly. If I store a dog pointer but treat it like a integer pointer, C will not stop me at compile time. Also, memory cleanup depend on the right free function. If the data has nested heap memory, like a dog with a heap string name, the wrong cleanup can leak the memory. So now polymorphism in Rust, the first feature, but now in Rust, here I wrote the linked list as a linked list of T. So T means the list works for any type, but the compiler still knows the exact type when I use it. I also use closure for operation like map, find, and remove. So here Rust gives me the same general idea as C callbacks, but with a stronger type checking. And yeah, here those output show the same linked list implementation, working with integer and dog structs. I did not write a separate list for each type, but compared with C, Rust version is more variables in the type signatures, but it gives better safety. The compiler know what type is inside the list. So memory in C, yeah, the second feature, which is in C. So in C, memory management is powerful because I decide exactly when to allocate and free memory. I think I use this in many projects like stack, linked list, word counters, and mark and sweep simulation. But does not really track ownership for me. For example, if I forgot free, I leak memory, and if I free too early, I can get a dangling pointer. And if I write if I write past the buffer, I can corrupt memory. And even now, here in memory in Rust does not use a garbage collector for normal memory management. Instead, every value has an owner, and when the owner goes out of scope, Rust automatically causes drops and cleans the memory. So in this example here, the box value is located on the heap, and then Rust drop it automatically when it leaves the scope. So yep, and the overall comparison, memory comparison. So the important point is that Rust is not a garbage collected like Java. Uh, it is closer to C because cleanup is deterministic, but Rust prevents many mistakes by using ownership and borrowing, where C where we don't have in C. For example, Rust does not allow two parts of program to freely mutate the same value unless the values are clear. This is a very big safety difference from C. So Rust stays close to C but moves more correctness check before runtime. And this is my very last feature, concurrency in C. And in the project A, the last project that we did, I use C pthreads for band force log counting, and the hard part is share data. If many threads update the same counter, I need a mutex. If I log too much, the program becomes slower. If I log too early, I can get a race condition. So C gives control, but the programmer we have to design the safety. Here in Rust concurrency, again Rust make sharing explicit, and so Rust also use threads, but sharing is more explicit. Like arg means share ownership between threads. Mutex means only one thread can access the value at a time. The move keyword show that data is moved into the thread. So Rust does not remove concurrency complexity, but it makes the rules more visible. So my final conclusion for this presentation is that Rust is a very strong system language because it keeps much of C's control, but it makes polymorphism, memory, and concurrency, those features, safer through those compile time, those rules. So this is the end of my presentation about three features from comparing C and Rust. Thank you so much.